All right, so now we're going to turn our attention to exponential notation. So let's dive into that. In chemistry, it's going to be really, really helpful to use scientific notation because we are going to be talking about very, very, very small numbers of things and very, very large numbers of things. And to do that, it helps to, use scientific notation. All of this is based on log 10 if you're familiar with that. So if we are going to write a number, let's say this number here, and I know that looks like a pretty small number, but that's not even nearly as small as sometimes we deal with. That number's kind of got a lot going on with it. We could write that number as a negative exponent, and we could do it this way. I could write this number as 7.50, okay, times 10 to the negative something. And let me show you what that negative number is. It's going to be negative 1, 2, 3, 4, 5, 6, 7, 8. So I'm just counting the number of zeros I have to go to get to that 7.5 slot. So I'm going to write this as 7.5 times 10 to the negative 8. And that's going to be a whole lot easier to write than to write this. This one is almost okay just to leave the way it is, but we'll use that as a negative. We'll use that in scientific notation too. In order to do this one, I'm going to report this as 4.35 times 10 to the negative 1, 2, 3. I just got to get that decimal point in between the 4 and the 3. So that'll be 4.35 times 10 to the negative 3. If I have a larger number, these are all numbers less than 1. If I have numbers that are quite a bit larger than 1, I do something similar to that. I'm going to report this number as 4.25 times 10 to the, I'm just going to figure out how many zeros I got to get past to get to, or actually how many digits I got to get past to get to there. So I'm going to say it's going to be 4.25 times 10 to the 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's going to be 4.25 times 10 to the 9. Pretty big, large number. This is a number that you might leave as is. It's not quite as neat and tidy, but it's still a pretty handy one to convert to scientific notation or exponential notation. This is going to be 6.8 times 10 to the 1, 2, 3, 4. 6.8 times 10 to the 4. So figuring out how to write things in exponential notation is not nearly as difficult as sometimes figuring out how to use your calculator. Calculators these days, a lot of them are associated with your phone, they will allow you to type in numbers in scientific notation. And that will greatly help you do some of the math that you need to do in chemistry. So let's look at some of the kind of problems that we have to do in chemistry and figuring out how to use our calculators. Anytime you are going to add or subtract, this doesn't apply for multiplication or divide, but if you are going to add or subtract, you have to get numbers that have like terms. So for example, this number here, 4.5 times 10 to the 4th, it has a like term with this 1.75 times 10 to the 4th. So you could add those two numbers together and come up with 6.3 times 10 to the 4th. We're going to have to round that up, of course, when you do it. You can add those two together, the 4.5 plus the 1.7, okay, 5, and because they both are in 10 to the 4th. It works that way with, just doing it by hand. Here we have a very different situation. Here I have 7.5 times 10 to the 3. Well, that number is really, really smaller than this number here, 5.25 times 10 to the 5. In order to add those two numbers together, I have to get them to where they have the same like terms. So I have to get them both to either 10 to the 5 or 10 to the 3. In this case, we're going to move them to 10 to the 3. So I don't have to do anything special to that 7.5 to get it to 10 to the 3. But this one here, I'm going to have to move this decimal place 2 places to get it to 10 to the 3. And when I do that, I end up with 525 times 10 to the 3. Now, I can add those two numbers. I can add 7.5 plus 525, and I would come up with an answer of 532.5 That's too many significant figures because I only have 2 there, so I'm going to have to report it to 2, and I'm going to, because my next digit is a 2, I'm just going to round down, and so I end up with 5.3 times 10 to the 5 is my final answer. Subtraction works much the same. So here I have 8.87 times 10 to the 8th, all right? And I have 9.3 times 10 to the 7th. All right, I'm going to subtract those two numbers. Well, I've got to get them both to like terms. So I'm going to move them both to a 10 to the 7th. So in order to get that 8.87 to be a 10 to the 7th, I'm just going to move that decimal point 1 over. And that's going to make that 88.7 times 10 to the 7th. Now I can take that 88.7 and subtract 9.3, all right, and I can come up with 79.4 times 10 to the 7th. Of course, now we have the same issue we did up here. I have too many numbers to match my significant figures. I've got to reduce that to 3. And so and my 4 is less than 5, so I'm going to round down. So I'm going to end up with 7.9 times 10 to the 8th. That's how we deal with subtraction and addition. Subtraction and addition with exponents is more difficult than multiplication and division. Multiplication and division, all you have to do is you can multiply the two numbers straight out, 3.25 times 2.2, come up with your answer, and then you can add the exponents, the 7 and the 5, and come up with an answer. So in this case, I come up with 7 plus 5 there, or 10 to the 12th. If you're using a calculator, of course, you don't even have to, monkey with that. You can just type in 3.25 exponent to the 7 and 2.2 exponent to the 5, and your calculator will automatically give you that final number. And while it is certainly possible to do these by hand and not use your calculator using scientific notation, later on, it will become really helpful if you know how to use your calculator and are able to enter exponents in your numbers. Another example here would be 3.25 times 10 to the 7. Multiply that by 6.2 times 10 to the 5. Well, we can do that simply by taking the 3.25, multiply that by 6.20, and then take my exponents. And because I have a minus 5 there, I'm going to say 7 minus 5, or 7 plus a minus 5. I'm going to end up with 2. That's what that number is there. So I end up with 20.2, and times 10 to the 2. I can simplify that by moving that decimal place 1 over and raising that to the 3. So that'd be 202 times 10 to the 3. To divide two numbers in scientific notation, you divide their coefficients and subtract their exponents. So, and the answer, once again, you're going to want to convert it to scientific notation just like we did up there. So we're going to divide 3.25 times 10 to the 5th by 2.2 times 10 to the 7th. So I could take 3.25, divide that by 2.2, put that number there, and then I could take the 5 minus the 7, okay, and I'm going to put that number right there. So I end up with 1.48 times 10 to the negative 2. And then our next number is 3.25 times 10 to the 7 divided by 6.2 times 10 to the 5. If I take 3.25 and just divide that by 6.20, I come up with 0.524. And then I'm going to take this 7 minus a negative 5, so it gives me a plus, minus a negative 5, and I'm going to end up with 12. And so my final answer is going to be 5.24 times 10 to the negative 13. And I have to look at that. That says negative 13, but that should be positive 13. I have a positive number, and then another positive number. That gives me a 12. I should not end up with a negative 13. That number's wrong right there. All right, let's look at some practice. If we were going to write this number here in scientific notation, how might we do that? If we go back to our rules, we're going to say, okay, scientific notation is going to have a number that's 7.24 times 10 to the something. And because this is a number less than 1, I know it's going to be times 10 to a negative number. So I'm going to say this is 1, 2, 3, 4, 5, 6, 7. 7.24 times 10 to the negative 7. And I'm going to allow you to work through the rest of these problems and give their answer in scientific notation.